Good evening, all.
I agree.
Engineer Alok Mishra has over 14 years of experience in the energy sector and leads Power Grid Asia Pacific at DNV. With an engineering and MBA background, he has led impactful projects in renewable energy, digitalization, decarbonization, asset management, and EV integration. He authored India's first offshore wind and hydrogen study and contributed to 4-bit grid connection report. He developed the asset management roadmap for India's discoms. Alok sir has received accolades including the Clean Mobility Leadership Young Achievers Award, a 40 under 40 distinction and recognition as of India's top 100 net zero leaders. Thank you, sir.
Alok, you can start. You can share your slide.
Okay, sir. Thank you, sir. Sir, my screen is visual.
Yeah, it's visible. You can put in slide mode.
It's fine, sir.
You just put. Yeah, it's fine now.
Okay, sir. Okay.
Yeah.
Thank you all. It's pleasure to have in this platform and this training session. So let's quickly start the topic. I will take one. Just introduce my company. So DNB almost 160 years. Norway-based company, and we are working globally, running more than 100 plus countries, and um, we at the DNB the charter, so we used to invest our 5% in the R&D, which is related to the recent industry challenges. So we have several different. I am belong from the energy advisory system. So I'm going to present about the offshore wind, and I hope you all are aware of the onshore wind, which is we have very we are top we are in the top 5 globally, and we are now moving toward the offshore wind. So when we come about the offshore wind, here I'm also differentiate about the onshore and offshore wind. So basically, when we talk about the onshore wind, it is on the land, and it is really can be the based on the wind condition we can install here. But when we talk about the offshore wind, it is only can be installed in the inside of the seashore, because in the sea we know wind speed is very high, and especially Bhubaneswar is, which is very near to seashore, Odisha, a very long distance of the sea. So this is one of the beauty of this offshore wind, without disturbing any land, because at today one of the major challenge for the any development is the land. Either is the we want to be bring factories, yeah, any electrical project, anything, yeah. In fact, in building in the house, the one of the major challenge today is the land. So these are the technology where we can help to get the energy, because that is also fact that in today that we can't live a single hour without energy. So this offshore wind really help us to develop and help supply the energy with the no land. So when we talk about this offshore wind, it is not a new technology. Like I'm taking example of the car. In 1886, Benz developed the first car, and 1955, we have the production almost a more than 1 lakh car. So now in within once and this as the technology moving ahead, in this last 130 years we move toward the electrical side. So this all technology development happening that is real. That's a similar implementation in the uh, this offshore technology. When we talk about the onshore and offshore technology, in 1988, the first wind test type was developed. In 2000, the first Siemens Gamesa developed the first offshore wind turbine with a capacity of 4 megawatt. Now 2021, it moved to the 7 megawatt again developed by the Siemens. And now in 2024, we about to means we are moving toward the 18 megawatt, and I'm sure some the way R&D is moving on in recent within few years we have the 20 more than 20-25 megawatt wind a single turbine will become. So in the lifespan of 44-45 years it developed like 3 megawatt to almost 7 times time with a turbine is developed. So when we talk about the technology wise, wind turbine technology is still in the new, and when it's talk about offshore wind, it's more than the new technologies respect to other. So why we need to go for offshore? Because in the seaside there is a better wind resource, better wind space. We have the more space, and another thing that the we know sea almost at the plain area and have the uniform wind high speed. There is no such type of blockage. Like when we talk about the land, uh, first of all, dating the for huge land for this turbine, it's really very tough at the present situation. Second thing, there is lots of blockage like railway line, sea, railway line, river, village, and other things are multiple things are there which can be affect the performance of the turbine because these all are creating obstacle and other things to the wind. But when we talk about offshore, there is no such type of blockage. There is no disturbance at all. And also there is no anything nearby like a mountain and other things there. So this all are the things it help. And in top of that, the capacity of one turbine where still the onshore is moving going 3 megawatt, 4 megawatt, 5 megawatt. In India, we can say average of 3 megawatt. But here the average itself is start from 7 to 8 megawatt. So almost double of side of the onshore is there. So this all the benefit it helping us to develop the move toward the offshore wind. Another problem with the one of the major drawback with the offshore is the cost, which we will discuss later. When we talk about the early days into 2000, there was a 30 megawatt turbine was installed in the different. This was the first when we say about that installation. The Denmark it was 4.95 megawatt. In 92 Netherlands 2 megawatt. This all are the prototype. These were all are the I would say R&D project were there, and these are the sequence the development happened. And now Denmark is the leader in the global offshore wind. These are the some few projects which commission very well, and they are in the running condition. In 2024, these are the one of the major the other bank project is there, which were the three sites and each one 1.2 gigawatt, which G was supplied 14 megawatt turbine. One turbine capacity was the 14 megawatt. And these are the installation of offshore wind. I don't have still received the 2024 the data, so I didn't mention about that. But you can see that in such a short period, it's almost moved to in the 10th times from 2014 to almost within 10 years. It is going with the because of just all benefit. So globally at presently means until 2023, 67 gigawatt globally operational there. So these are the how this development happening throughout that in where I will just focus on the when it was in 2000 the multiple developers came, and now in 2020 the first 15 megawatt prototype are developed, and these are the some of the wind farm developed, and now there are expected that Germany moving toward the because Germany moving toward the complete renew they have the coming with the 7 gigawatt a single project at present. These are the how Norway, Netherlands moving toward the renewable energy roadmap, and these are their roadmap plan. So when we talk about the history, we can say that offshore wind technology had developed faster than in the past 2 decades. Technology development uh, is still it's on the moving direction, and it's really good for anything. Then when it always come up with the new technology, and it's also moving toward the globally multiple country is growing fast, and in India also our government of India come up with the plan, and we are working towards the uh, first wind farm, and our plan by 2029 5 gigawatt or 1 gigawatt plant in Gujarat, and 2031 another 1 gigawatt plant in the Tamil Nadu. So when we talk about the major component of the offshore wind, it is similar to the onshore wind. The only difference is their cable to the seabed, like from seabed, because this all are inside the sea. So it is connected to the cable from the seabed to the nearby substation, which we will discuss in much in the later slide. Now I'm just comparing a high level on that. Onshore versus offshore. So when we talk about this, onshore is the cheaper to build. Like uh, means uh, cheaper in sense I'm talking about two sense. One is that cheaper, like the cost is very low. Second thing, because there is lot of technology development happen because of that. And another is the installation type also very less. Like within 1 year, now people are developing 1 gigawatt in the single location, which is not the case for the offshore wind. Also, because these all are the capacity in one single plant go up to 400, 500 megawatt. So we have the shortest cable and we have the less power losses because of the shorter distance. Also, I mentioned it is quickly installed, and the impact on the natural is very low because we this all are the coming on most of the region we have other things are not like I'm taking example of Jaisalmer. In Jaisalmer is completely full of sand. We know Jeddah is there, but there is loss because of those Venus is very good, and there is loss of also the wind turbine is there. And this all are turbine in the land, so it is easy to do on the operation and maintenance for them. But when we talk about the benefit of offshore wind, it's a better wind consistency, as I mentioned earlier, because these all are have the sea entire the sea have the almost same wind speed that particular zone. So there is no such type of a no such type of issue is there. Uh, Also, because of area, the wind speed is all very stable, and the capacity is also very uh, like one turbine in the offshore it is 2 to 3 megawatt. I'm talking about Indian situation where offshore we are planning around 7 to 8 megawatt a single turbine. So almost 2 to 3 times of capacity. But when we talk about the negative, yeah, back, yeah, the his impact. So when we thought about onshore wind, the wind speed is intermittent, and that is we know very well. That is one of the major challenges the onshore wind. When we need the energy, when we not need the power, there is no surety about that. The wind will be there. Second is being blockage, like because of building, forest, village, and many other things are there. Village areas are there, which impact the wind speed, and that is the when wind speed is not impacted, the generation also got impacted with that. Uh, Apart from that, the visual and noise impact, because this all are if you have some time, you just go to the near to Kanyakumari, one village is there. In the night, it is very tough because all turbine are the older turbine, and there lots of noise are coming, and people are always blaming for that. Uh, and also with the respect to offshore, the capacity vector is very low. When we talk about the uh, when we talk about the offshore wind, because of this, all are turbine in the seashore inside the sea. The maintenance is really very tough, and we have to the uh, means we need too many safety and other concern to go when we go for the maintenance. Second thing, the more expensive to the build. One of the thing which is really going challenging to the world about the construction phase. It is very high because of the sea, because of technology, and because of the local manufacturer. Like I'm talking about India. In India, at present, we don't have any offshore wind developer and manufacturer. We have lots of onshore wind developer, like we have the Sulon, one of the business leader. But when we talk about offshore, we don't have any. Anything we have to be bring from the Europe. So this all things are making the uh, costlier impact for us. Another thing is that marine life, like it is all are in within the sea. So the fish and fisher are they are good getting challenge from those things. And these are the things happen in the Denmark where fisher were really struggle to get the fishing because that is their main resource. And that life got impacted because of this offshore wind. Later on, the government come up with their some plan and other thing happen. But this is one of the major challenge is there. So when we talk about the levelized cost of tariff, levelized cost of tariff is like that when we talk about the lifespan of the wind turbine, uh, how much uh, energy, yeah, how much cost is there. So turbine capacity percentage of when we consider the offshore is around 70%, and offshore is 45%. Offshore longer repair time and also longer cost. These are the complete layout of the offshore wind, how it is. So first, there is turbine is there. Turbine is connected to the cable arrays, uh, and these are the onshore substation, which is like there is multiple like turbine connected to this substation. From there, this uh, offshore substation they are connected with the onshore substation, and from onshore substation, the power go to the grid. So these are the better means these are the basic principle how it look like. Uh, and when we talk about the element required to develop that, first is the designer. Obviously, anything like when we build going to build a house, we first need to be we used to do the design of a house, and based on the design, we go for the and we prepare the list of things. What are the things we need for that? And based on our list, we go choose our vendor, whoever we supply. Like in the home, who can be price who can supply the cement, who can supply the bricks and other things. Like same way, we here also we will do the same way. And after that, we do the pre-assembly check. uh, and then we'll go for installation, then commissioning, and after that we go for operation and maintenance. These are the turbine. So these all are the foundation. This and now I'm going to more focus on the how electrical infrastructure are there. So arrays double link, the two major things are there. One is the array cable. Array cable is connected between the two turbine, and then array cable is connected to the offshore substation. Then offshore substation is connected with the onshore substation with the help of export cable. Export cable is supplies the power complete to the grid. When we talk about the voltage level, the array cable is generally 32, 33, and early days were there. Now it's moving to 66, and also now technology moving toward 132 kV. But in general, at present, the array cable generally in 66 kV. When we talk about export cable, it is generally on 220 kV, yeah, beyond. Beyond. These are the uh, addition turbine capacity, bigger turbine capacity. These are the when we do for the offshore wind farm contracting. This it is very complex process because of its nature and also because of viability. Because these all are things in within the sea, so we have to be go very longer process. So the major when we this table explain about the what are the value chain is there and how supply chain is go. Like when we go for the design, uh, supply transportation, it is goes with the WTG supplier. When for installation, we go to the marine contractor who had the expertise in the installation of wind turbine. Then we have the for commissioning and random again we have to go with the WTG supply because they know how um, uh, do the commissioning and for the random it is uh, uh, we go with the harbor. Just to make it simple, like when we go for purchase of TV is design, supply, transport, and everything with by the uh, manufacturer. Yes, supply. Like I'm talking about when we go for the LG TV, what people are do LG showroom, they have everything is packed, everything is ready, and based on our selection, they supply. They we pay the TV and they supply our home. Now the supplier you supply the TV at our home. They are not the LG guy. They are the contractor. So like same way here, they are coming for contractor, and those guys also come in for the installation. Now LG guys come to our home and they do the installation and they teach how to run and other things. That is the same philosophy happen in the turbine also, and these are the other thing happens differently. I'm going to more focus on the second last one, offshore work, because this is something very crucial as an electrical engineer. When we go for the export table and substation, we first to design, we have to do the very detailed study. We have to do the power flow study. We have to do the short circuit study. We have to do the transient and other study, reactive power study. Uh, as per the grid requirement. And based on a study, we select the cable, we design the cable, and then based on that, we will go to the OEM supplier. OEM supplier, based on our specification, based on our study, they manufacture the cable. This is one of the lengthy process here. Like if let's suppose that if you have planned to install it, a wind farm of let's suppose that 1 gigawatt in 2020 30, you have to be ordered by 2020 because generally this there is a limited cable manufacturer, export cable manufacturer across the world, and their waiting period is 6 to 8 years minimum. If you have if you go some major project, then it is maybe go more than 10 years also. And this is one of the major cause where at presently the European offshore wind development is going very slow because of one of the reason is the export cable cost and the supply chain of the export cable. When we talk about the wind project life cycle, so basically when we it is like a some like a of general basis we can compare when we have to plan to purchase a car. Like when we have to plan to purchase a car, first we check the feasibility, which type of car is feasible for us. Like I'm taking an example in the in Europe, they have the left steering. We have the right steering. So if we directly bring those car in our India, that's not going to work because of the road, yeah, because of traffic situation. So like we need to do the feasibility for that. The same way we will do the feasibility, and also we will uh, uh, check what are the easy to the like there is also possible that the which car we need. The time period, waiting time period, maybe 10 years, 5 years, that's so long. So we will go for the based on our requirement, we do the feasibility. Same thing happen in the here also. Then we go on the development phase. Development phase for offshore wind, it go several years, almost 3 to 4 years minimum. We have to be and considering this year based on you have all the expertise. But when you go in the initial period, you go more than that 4 years also. Uh, and in the development phase, also consider like a feasibility development and engineering. In engineering phase, we do all the engineering paperwork, like what would be the substation size, how substation will look like, what are other things need to be do, how much reactive power, reactive compensation need. This all thing will do the engineering. Then if we go to the construction phase, the construction phase also take almost 3 to 4 years minimum based on the size also and then it go for operation uh, it go for the 20 to 30 years. When we now I'm going to on development of the offshore wind. So when we think about the development, one of the major thing is coming environmental factor because this is a very crucial uh, thing, and we need to for that lots of study and lots of approval also, like the border situation. Always we know the sea area is always border condition for any country. Like in India also we have the limited sea area, not like that all the sea which is covered surrounded by India, all are within us. So based on that siege area and the sea area, whether it is some sea area belong to the defense, some sea area go for some marine research and other things. So those all things need to be tested. And second thing about the uh, how sea are behaving, how sea are look like. We know that every time there is a wind rest and other impact are there in the sea, and that can be like many we observing loss of impact. Odisha is the one of the example where uh, always every year lot of typhoon and other things are coming. So how those things will be the not impact our wind farm. So those environmental factor is one of the major things. Second thing, then once we have those things, then we go for the technical factor, technical design based on the environmental study. And third one, based on that, we go for development. So when we and the major thing when we come about that, these four major thing it come: wind speed, wind depth, seabed, and distance. Because our major costs are depend upon this four factor. Um, so LCOE. These are the when any company, any investor want to be develop the wind farm, offshore wind farm. This they go with this trilemma, like what are the energy live or energy alive, or like how much energy I can get from that particular wind, and what would be the duration, and based on that they do what are the capex I have to be invest, and how much operational cost will be there. These are these measures when we go they go for the LCOE calculation, and these are the three major factors for anything. Like like I'm taking example, as an engineer, we can develop a machine whose efficiency is more than 100%. But do that machine is really sustainable, cheap, and good for the market? Yeah, good for us. That is we need to be defined. If let's suppose that any machine is 100% efficient, but the cost and the maintenance is very, very high, we will go lesser efficiency. We will not go with the just for efficiency. So like same way we have to go with this trilemma. So when we do the financial model, the means the site development feasibility, what are the inertia CapEx costs are included in all the assets, including the export cable and onshore work. Because these are two major factors because of, as I mentioned earlier, the cable is really very, very, export cable is very challenging nowadays. And second thing about the workship. Like in India, as presently we don't have the expert engineer who can really work on the offshore work. Most Mostly people coming from the Europe. And when we compare with the cost rate from India and Europe, it it's too much high. Almost what are monthly there, that is almost their daily rate. So these are the issues we have, and these are the when we do the costing, we have to be see this all the factors. And these are the project life cycle. Like from operational to government agency, then we have to go for the uh, general life cycle around 7 to 8 years. But this is now things are improved, and now things are destined ready. So now time is reduced, but this I'm talking about the standard timeline, which is generally like 2 to 3 years. We have to sit with the government agency. We have to be get all the approval in the place, like marine approval, CVT approval, and other grid approval. Then we based on all approval, we go for developer, then contractor, and then we have our wind farm ready. So these are the life cycle who are the major contributing stakeholder in there. Like in developer who want to be developed the wind farm, they go to the local and regular government department for different approval. Then they go to the environmental impact study. Apart from that, they also land or because sea is not belong to anyone, it belong to government, so they have to be go government, and also the near seashore. We have some land we need offshore stuff and other thing, so we have to go for that. Then we go for the turbine manufacturer, then contractor, off-taker, DSO, TSO, then lenders who can lend their money in project, and then investor. So these all are the major stakeholder in the any offshore wind. When we talk about the means these are the key factor uh, like for the any project like contract n- uh, uh, for balance of plant like substation and other thing, we have to we have to negotiate with contractor, then project execution, license permit emission, and then also we have to need a due diligence for those things. So the the moving towards this three-phase area, concept engineering. When we know our how much area we have, based on that, we do the wind resource assessment of the turbine, and based on that, we know how many turbine we can install in that particular area, which is given to us. Based on that, we do the feed study. Feed study is basically how turbine will be installed, how substation will be installed, how what are the type of turbine we need to select, and other thing, everything we do inside the feed study. And based on the feed study, we go for the execution and design and study. Uh, when generally there is two process to develop the wind farm here. One is the multi-country and second is the EPC. In multi-contracting is a bit headache one, because you have to be each and we have to be uh, like contractor for each and everything. Like for turbine, you have the separate uh, contractor. For installation, you have the separate contractor. For cable, you have the separate contractor. For installation, you have the separate. Like each and every have the different contractor, and the developer can do this and can have the machine connecting with all them. But when we thought about the EPC, EPC is uh, um, basically developer who want to develop that. They directly giving the complete contract to one party. That party generally responsible for entire things. And this is also like, let's suppose that they go for the turbine one. They for construction and installation and commission they go one, and for maintenance they go for one. So like this is how things are there. But in general, when there are multiple parties need to be contracted, that will come under multi-country. And when more than less than three, between 3 to 5 in between there, then that will come under EPC. These are the decommissioning phase, how decommissioning happening uh, within the offshore wind. Now I'm going to how supply chain are there. Like when we talk about the turbine, in turbine, the major development of is cement, Vestas, GE, Goldwind, and wind power. The major player is Vestas and GE in offshore wind. When we go about the foundation supply, these are the company. It's there, and these are the installation cables. LS cable is one of the main one here, and offshore substation Semcop and Petronaut is there. Now I'm talking about the India, more specific to India. So at present in India, done the Fobin study, and based on the Fobin study, we identify two places at present where we can go with the offshore wind. One is the Gujarat, which this area, like these are the Kutch area, we can say. And second one we identify in the just near to the Rameswaram, which is Gulf of Myanmar, it call it. And these are the zone we, based on the wind speed and other thing, we decided the zone, and these are the area we have. And this also mention about the how much distance is there. Like I'm taking example in Gujarat, zone A is here, zone one, zone A is here. Uh, Zone one is here. In zone A, we the water depth is 24 meter. Wind speed is 7 meter. Here, distance from the substation, distance substation is 23 kilometer, and area is 196 1921 kilometers. Right. So these are based on Ovin study. We did this study. So now, when we come about the subpressure wind farm, one of the thing is that offshore wind is and like any foundation. So there is around uh, uh, five type of presently substation is there: monopile, jacket, gravity weight, suction bracket, and floating. Monopile is like inside the sea, we just hold and we just make one pole like a like onshore wind. Second is the jacket. It is we just make a tripod and put inside the install in the sea. There is a gravity weight. These are the in the rough sea area we used to do this one. And sectional bracket is where sea is rough, mean in the rocky and other thing we use to that. Floating is a very new concept and it is still not fully fledged applicable everywhere. So how like if uh, like bottom fish is monopile in mean bottom fish when we the bottom is fish it generally monopile it goes with the 50 meter uh, uh, less than 50 meter. Gravity we go less than 30 meter. Jacket go with 60 meter tripod. But when we get about the floating, these are like anchor based. Uh, we do the installation, and this is go up 30 meter. Now I'm going to talk about the challenge. Uh, you know, about that. So this table is very important for us and this is also the things where we can think about that whether offshore wind can be the future for us because there is lots of projects globally coming and these are the major players across the globe. India is still not there because we are still under process installation is still under the mean under discussion not really everything is finalized so that's why India is not there. But when we talk about the material supply. In India, we China, South Korea, and Japan. These are the major one. The this so these are the challenge because mostly like cable and other thing are going to be from these three country only. When labor and experience, these are the one of the major things where we can think like in the across the globe, only few countries have the labor and experienced people who really work on the offshore wind. Uh, but the development is very high. In fact, when in India we go for the installation committee and development phase, we have to bring expert from the this country only, like UK, France, Norway, Germany, China, and Korea is only for the product side, not on the real development side. Like for installation committee and O&M, we have to be basically dependent upon the Europe only. So these are the one of the challenge for us. And cost because of that, cost is also going very high. So this is from the my side. If any question, please let me know.
Participants,
Sir,
any question? So you can ask the question in chat box also. Any questions, participant?
Okay, so we don't have session, but still we have 4 to 5 minutes left. So let me explain something about the offshore challenge in India. And I'm not going to with any slide. I will based on my recent experience discussion with the ministry, other stakeholders. The one of the major challenge what we have, one is the electrical infrastructure. Like electrical infrastructure or uh, electrical infrastructure, one wind farm, each coming with the capacity of 10 megawatt, 20 megawatt, gigawatt, not in, sorry, not in gigawatt. Uh, so how grid can be the developed in such a capacity? So for that, and another thing is the load center of, for that. So these are the challenges we are facing at present. Second thing about the uh, equipment and other things. Like we know we don't have very good relationship with China, so we are avoiding to bring any material from the China. So mostly things are going to come from the Europe, but the European are so means they are they have too many projects by themselves. So the delivery time what they are committing to India, that is really going to be challenging for us. And also that is one very generic thing is that when they increase, cost is also increased because of the influencer. So those are the getting material on the time is the one of the major challenge. And third one about the resource, like human resource. We don't have anything, uh, any uh, uh, anything is there, any resources there, any institute, anything are there who can really train the person a resource who can give and directly work on the offshore wind. And also the expert who are there means also expert like installation, like cable installation is very crucial. So in those things, it's really those challenging things. We don't have any one experience. So because of this, 99% things are coming from Europe, either equipment, air resource, everything. Cost is really going, but getting very high. So how we can move ahead with that? With respect to that, when we talk about like in general, that presently the per unit cost is coming around 7 to 8 rupees per unit cost. But at presently the solar cost is still the 2 to 3 rupees, almost 3 times of that. So who will be buy this? Who will buy the electricity in such a cost at present situation? So these all are the things which is challenging us. And these are three major block placements. So I saw some question about here. So
Yes.
first, yeah, what about pitch engine control in offshore? So though it is just like a onshore wind, uh, that. So based on the uh, uh, adjustment of the wind turbine blade with respect to the uh, wind speed to generate the maximum power. Uh, and it is family, it is completely now automatic in offshore. Also, it is uh, onshore also it automatic, and offshore is also automatic. Basically, based on the things like center and controller control that one. Yes, yes, high speed is there, but the thing is that wind speed uh, has constant. It's not like uh, the major use for the pitch control is controlling to maintain to bring the direction. Yeah, rotating the blade based on the wind speed. But here the direction is very constant, and the speed is also almost constant in particular duration. So the wind turbine itself is sufficient to maintain the pitch, maintain the pitch, their pitch and length. And it is much easier than the of onshore wind. because here onshore wind direction and wind speed changing very frequently, but in the seaside, whatever wind speed is there, they long for the duration. And one of the, as I mentioned earlier, the intermittency is one of the major challenge in onshore wind, but offshore wind that is not that much challenge. Now, you might have another question like that: how we that turbine can sustain the very high speed? Yeah, when it's going very, like, let's suppose that our design is like 20 kilometers per hour, and wind speed is going for 40. So that's the reason when we do the assessment, environmental assessment, based on that we know what would be the maximum wind speed can be there. And based on that, we go for selection and go for protection. The role of meteorological department is basically uh, 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 their role in during the construction is very less, but their role during the O&M is very high, because they want who predict what would be the tomorrow temperature, wind speed, and other things, and when can any typhoon or anything going to come. So those are the things on the O&M point of view that is very important. But when we are the project is under installation and commissioning phase, under, we can say, in the development phase, the major thing coming from the marine department, because they know sea better than anyone. So their input is very important during a construction. But meteorological department is morely play a role during the O&M, and this is also applicable for the onshore wind also. Now, how reactive power requirement is addressed? So basically, the reactive power is measured based on the one of the major thing is that cable. So for that, based on the when do the pre-feed study, we know how much reactive power is required, and based on the regulation, we on the offshore substation also we put the reactive compensator like STCOM, SVC, and if required, yeah, if you have to fulfill the grid flow also some in the seaside also, in the source substation also we need to uh, install SVC. So basically, in the short, SVC uh, fulfill the requirement of reactive power. Thank you.
So, if you have further questions, you can ask. Otherwise, we will close the session. So, thank you, Engineer Alok. Alok, in fact, is my student from MGR University, Chennai. He has a long experience in this field. He's working for a long time in DVN. So, thank you, Alok, for your expertise. It's truly appreciated.
Thank you,
and,
sir. Wish you are blessed, sir.
So it's around 15 to 18 years, I think, no? So
yes, sir.
You graduated on which year?
In 2010. 10, I passed, sir.
2010, yeah.
Yeah.
Yeah. So thank you very much for your time. Okay.
Thank you,
we'll
sir.
be in touch.
Sure.
Thank you,
sir.
Alok.